Welcome to ReneEnergy.com on YouTube, the hub for all things renewable energy and sustainability.
Introducing ThermoLoop, a groundbreaking innovation that enables the production of green hydrogen without the need for electricity. By combining heat and water, this startup has found a way to generate green hydrogen, eliminating the need for expensive electrolyzers and paving the way for a more sustainable hydrogen economy. Green hydrogen holds the promise of being the holy grail of clean energy, offering zero-emission fuel for transportation, steel production, fertilizers, and long-term energy storage. Its potential to decarbonize the hardest-to-electrify sectors of our economy is massive, making it a key player in the future of sustainable energy. However, there's a significant hurdle. The cost of green hydrogen is still too high for widespread adoption. Currently priced at $4 to $6 per kilogram, the target is to reduce this to $1 per kilogram, a five-fold reduction. Without such dramatic cost reductions, green hydrogen will remain a niche technology. A closer look at the cost breakdown of traditional green hydrogen reveals that electricity costs account for a staggering 70% of total production costs. Every fluctuation in grid pricing and every hour of downtime directly impacts profitability, making electricity the primary cost driver in hydrogen production. The current reliance on electrolyzers presents several challenges. They require rare materials, depend on grid access, involve complex systems, and are prone to failure points. Imagine if we could remove the electrolyzer from the equation entirely, simplifying the process and reducing costs. Meet ThermoLoop, a game-changing innovation developed by NewHydrogen. This US-based company is working on next-generation hydrogen technologies, using industrial-grade thermal energy recovered from existing processes. By harnessing wasted heat, ThermoLoop can produce hydrogen without plugging into the grid. The science behind ThermoLoop involves a chemical looping process, where a series of thermal reactions pull hydrogen from water molecules without high-voltage electrolysis. This process is based on well-understood thermochemical principles, configured to minimize emissions and maximize efficiency. Here's how ThermoLoop works, step by step. First, metal oxide material is heated and reduced using high-temperature waste heat. Next, the reduced metal reacts with water vapor, releasing pure hydrogen gas. Finally, the metal oxide returns to its original state, ready for the next cycle. The only inputs are heat and water, and the only output is hydrogen. Waste heat is everywhere, and ThermoLoop can capture this waste from various industrial sources such as steel mills, chemical plants, power stations, cement plants, refineries, and data centers. These industries routinely vent unused thermal energy, which ThermoLoop can convert into valuable hydrogen. ThermoLoop is set to revolutionize costs in hydrogen production. Traditional electrolysis costs $4 or $6 per kilogram, but ThermoLoop aims for less than $1 per kilogram by using free waste heat, eliminating the need for electrolyzers, and being cheaper than fossil fuels. Achieving this target would make green hydrogen cost competitive with natural gas. ThermoLoop offers several technical advantages, including simplified operations with no complex electrical systems, modular and scalable deployment, robust performance with fewer moving parts, and lower maintenance. This system is inherently more reliable than traditional electrolyzer systems, making it a superior choice for hydrogen production. ThermoLoop breaks free from the dependence on expensive and scarce materials required by traditional electrolyzers. By using abundant and reusable materials, ThermoLoop eliminates the need for rare elements, stabilizing supply chains and reducing costs, making hydrogen production more sustainable and predictable. ThermoLoop is perfect for industrial clusters such as steel mills, chemical plants, refineries, and cement production. Imagine a factory not only making its core product but also generating hydrogen on site from its own waste heat, turning a byproduct into a valuable resource and enhancing sustainability. ThermoLoop's global accessibility makes it ideal for remote operations, including mining sites, military installations, developing nations, and island communities. It works in regions lacking strong electricity grids or access to renewable energy, providing energy independence and reducing reliance on imported fuels. ThermoLoop can create a direct path to hydrogen through solar thermal synergy. By using concentrated solar thermal energy to create extreme heat, ThermoLoop can efficiently convert sunlight into hydrogen without grid dependency or electricity conversion losses, offering a sustainable and renewable energy solution. Data centers present a modern infrastructure goldmine, with 40% of their energy becoming waste heat. By harnessing this waste heat, data centers could become hydrogen production facilities, serving digital infrastructure while generating valuable fuel. This closed-loop sustainability is a perfect example of turning waste into wealth. ThermoLoop has the potential to reshape the hydrogen economy by enabling smaller projects, faster deployment, decentralized supply, and new business models. By turning waste heat into revenue streams, ThermoLoop could transform hydrogen economics, making it as accessible and impactful as solar did for electricity. ThermoLoop is making significant strides in its development progress, with early-stage prototypes completed, successful lab-scale demonstrations, and commercial deployment scaling. Having proven the concept works, the focus is now on scaling to commercial viability, bringing this innovative technology closer to widespread adoption. As with any emerging technology, ThermoLoop faces challenges and next steps, including scaling up to industrial-scale systems, integrating with real-world heat sources, conducting long-term performance validation, and securing investment. The potential upside is massive, and overcoming these challenges will be key to unlocking ThermoLoop's full potential. ThermoLoop represents a paradigm shift in hydrogen production, moving away from complex, power-hungry systems to something more resilient, affordable, and scalable. This means faster deployment, cheaper production than fossil fuels, decentralized supply, and independence from grid infrastructure. The next big leap in green hydrogen might not come from electricity at all. It might come from heat.
Thanks for tuning into the ReneEnergy.com YouTube channel. We trust you found this episode and